Hi everyone. Today we will be taking a look at the quadratic formula. What is it? How do you use it? And when do you use it? So, quadratic formula right here in front of you, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, okay, cool. What's it for? So the quadratic formula is used to solve quadratic equations. So you can use this to solve equations where 0 equals ax squared plus bx plus c. So that kind of starts giving you an idea of what the b, the a, the c, what do they stand for. So let's get a little bit in depth. You use the quadratic formula when you have a quadratic equation. So a quadratic equation is it has to be an equation, so there's got to be an equivalency, and you have to see that equal symbol in there. It needs to be quadratic. What that means is your highest degree is going to be 2, so that the highest power you have is the second power. It is not quadratic unless it has the second power in there, x to the second power, and it is not quadratic if the second power isn't the highest power for your variable. Using the quadratic formula, we generally want to use single variable equations here. So you will see that this equation is set equal to 0. So if you've got a lot going on, but you've got a single variable quadratic equation, you can set everything equal to 0 by balancing it out to 0. You can add, you can subtract, get everything over to one side, and once you've moved everything over, what should be left on the other side is 0. So 0 needs to be equal to ax squared plus bx plus c. And finally, the explanation of a, b, and c, they are coefficients or constants in this equation. They will be real numbers. Your a will be the coefficient of the x squared value or term. Your b is the coefficient of the x to the first power term, and your c is the constant term. So just as a reminder, quadratic equations or quadratics can be modeled with a parabola. So a parabola kind of is that U-shaped equation because x squared, you can always square a negative or a positive. For example, negative 2 squared is 4 and 2 squared is 4. So when we raise something to the second power, you're multiplying it by itself, and that ends up giving us this parabola-shaped graph. So just so you know what it looks like, what you're connecting it to, that's a quadratic when you graph it. So we use the quadratic formula to solve for the value of x when the equation is set equal to 0. So if you take your coefficients and constants and plug them into this formula, evaluate them into this formula, using substitution, you will be able to find the values of x. And you heard I said values, so there's going to be 2 values of x in a quadratic equation, and that comes about because of that plus or minus situation here. So we've got the basic format, that's our skeleton. Now let's go through and solve an equation. So you will see here that I've got the equation 0 equals 6x squared minus 10x minus 56. So this is what we're going through and solving. So we're going to solve that using the quadratic formula. You will notice I've got my quadratic formula tacked up here on the left side of my graphic organizer. So whether or not you are given a graphic organizer, especially when you're first learning this formula, but really in general, especially if you sometimes make mistakes with positives or negatives, it's a really good idea to set yourself up a graphic organizer. So I have my quadratic formula right here. I'm going to figure out, looking at my initial equation, what my a value, b value, and c value are, and then I'm going to be able to substitute it in using this graphic organizer. So if we zoom back out, we can see that the graphic organizer helps me go through step by step. And the nice thing about a graphic organizer, you can create one yourself. You don't necessarily need someone to give it to you as long as you have a model. So let's go through. If I am reminding myself correctly, I'm checking to make sure, yes, this is in the form 0 equals ax squared plus bx plus c. So what that means is my a value is the coefficient of the x squared term. So that is going to be 6. Now my b value is going to be the coefficient of my x term. Now here's where I want to be careful. I see 10, but I have to remember the initial format is positive, so if the sign changes, I have to bring that sign change with me. So my b value here is -10. And then finally, I'm looking at my c value. C value is the constant term, the number that is not a coefficient. So -56, again, sign changes come with me. So my c value is -56. So it can be intimidating when you're first substituting this into your quadratic formula. I am a big proponent of using color coding to help me with making sure things stay in the right spot. So let's set up that color coding. I know I've used C, I've coded C as green, A is pink, B is light blue. So let's go through. I'm going to notice every time I see a B value. Those are the first 2 things that I need to substitute. My A values here and here. So the next thing in the top part of my formula, and it is the only thing I need to substitute into the denominator of this formula, and C only shows up once, and it's the last thing I substitute into the numerator. So now I can go ahead and substitute, and I know that my B value is -10. So we're going to throw that in there. And then my A value is 6, and my C value is -56. So you can see the utility of the graphic organizer kind of lets me throw stuff in as long as I'm following through. So once I have my bones, essentially, I just need to build off of it as opposed to having to restructure every time. So now the next question is, okay, I've got everything substituted in. What do I need to do next? Well, the short answer is I need to evaluate. But in order to get my answer correct, I need to make sure that I'm evaluating properly. That's making sure I'm paying attention to operations, paying attention to signs, paying attention to what it is I need to do in what order. So the first thing I tend to do is to try to eliminate any parentheses. So I see a parentheses here. So that's negative of -10. So the negative, my invisible coefficient there would be -1 times -10. A negative of a negative is a positive. So all that needs to do is become +10. Not always going to switch the sign. I just have to pay attention to what that negative is making me do. So now I'm looking in, next step would be -10 squared. -10 times -10, -10 to the second power. -10 times itself, many different ways of putting it. They all mean the same thing. It's -10 times -10, which is going to be 100. Because I remember a negative times a negative is a positive. And now, this is where I got to be careful. I have a -4 times a +6 times a -56. So here's the trick that I tell people here. Throw it into the calculator, 4 times 6 times 56, that's going to be 1,344. But I'm technically subtracting -1,344 if I maintain that negative, because 4 times 6, that's +24. 24 times -56 would be -1,344. But here's the cool thing about this graphic organizer. A negative subtracting a negative, that's addition. I can just turn that negative into a positive. Again, not something you're going to do every single time. Pay attention to what the signs are telling you to do. So I've taken care of this set of parentheses, this set of parentheses, and now I just need to deal with my multiplication in the denominator. 2 times 6 is 12. Now, next step, do my addition. 100 plus 1,344. Everything else stays the same. 10 stays, 12 stays, 1,000 plus 100 plus 1,344 is 1,444. Next step, I take care of the square root. So square root of 1,444 is 38. Everything else stays the same. And this is the point where I really do my splitting up into my two answers. So you'll see that I've maintained my plus or minus throughout this entire equation. Now it's time for me to break them up. And you can see in the next step of my graphic organizer, I'm adding on one side, I'm subtracting on the other side. Essentially, all I'm doing here is copying down what I've got, but now I'm just focusing on adding and subtracting, splitting it up into two possible solutions. So now I deal with my addition, I deal with my subtraction. 10 plus 38 is 48. Then I just have to divide by 12 to get one of my final answers. Get refocused, which is 4. 10 minus 38 is negative 28 divided by 12. Now that's not going to divide in equally, so that's not going to give me a whole number solution because I know 12 goes into 28 2 times with a remainder of 4. So I'm going to have to simplify my fraction here. I know both of these are divisible by 4. So when I divide negative 28 by 4, I get negative 7. 12 divided by 4 is 3. So my final fractional answer would be negative 7 over 3. I could also do this as a decimal and round it, which would give me negative 2.33 continuing. So those are your possibilities. So, but we typically like to leave those answers in fractional form. So the solutions to my equation 0 equals 6x squared minus 10x minus 56 are x equals 4 and x equals negative 7 over 3 using the quadratic formula. So what that would look like as a graph, you will notice here, zoom out as much as I can, there we go. So you'll notice here that I replaced the 0 with a y so that we could graph it, because graphs need to be bivariate. You need x and y, an input and an output. But you can see that where this quadratic equation or quadratic graph crosses the x-axis is at negative 2.33 and 4. You'll notice that the y value for both is 0. So what that's telling me is when I substitute 0 in for y, x is going to be negative 2.33, continuing, aka negative 7/3, and x is going to be 4. So going back to this gives you essentially where your quadratic equation would intersect with the x-axis, your x-intercept. So a lot of stuff to put together. Now, a couple things just to think about with the quadratic equation. You've by this point learned factoring. That's one way to solve quadratic formulas. So, keep switching those terms. Factoring is one way to solve quadratic equations. The quadratic formula works every time. It would be very difficult to factor and find a fractional value. So the benefit of the quadratic formula is it always works. The drawback is there's a lot of steps to it, so it leaves you more space to make little errors, which can then impact your final solution and could make you make a mistake along the way. So things you need to be really careful about are making sure that you know your order of operations, making sure you're applying them properly, making sure you're checking your work. Where I see a lot of people make mistakes is they have a tendency to mess up the sign right here. Sometimes they forget to recopy the division by your denominator. Sometimes they mess up the sign right here. So make sure you're paying attention to your signs, make sure you're paying attention to what your steps are. That's where the use of the graphic organizer comes in if you're utilizing it properly. So quadratic formula, here's another way that you have to solve quadratic equations.